Okay, welcome to Limits Lesson 4. In this lesson, we're going to look at an intuitive approach to solving limits with absolute value. I have to tell you, honestly, that the way that I'm going to teach this to you is probably not the way that your teacher will teach it to you. I teach it from more of an intuitive perspective. Hopefully, by doing it this way, when your teacher introduces her method or his method, it will kind of make sense to you, and you'll understand why they're getting the answers that they're given. But what I want you to see, now this is not in your notes, so I just kind of want you to pay attention to this. We know that if we divide anything by itself, the answer is 1. Any number, x divided by x, is 1. X plus 8 divided by x plus 8 is 1. X minus 5 divided by x minus 5, we know is 1, correct? So how does this change when I add absolute value? Well, this quantity doesn't change. The only thing that changes is that what's in the absolute value is always positive. So whether or not this is positive 1 or negative 1 really depends upon what values of x I choose. If I'm choosing numbers slightly smaller than 5, then my answer would be negative 1 because the top is always positive. But if I'm choosing numbers slightly smaller than 5, my bottom is going to be negative. So this answer would be negative 1. The same thing here. If I'm choosing numbers slightly smaller than 0, or if I'm choosing numbers less than 0, my answer would be negative 1 because the bottom would always be positive, but the top would be negative if I'm choosing numbers less than 0. So if I were to write the statement, the limit as x approaches 4 of x minus 4 in absolute value over x minus 4. Now I know because I'm dividing by the same number, they have the same what we call magnitude. If you ignore the sign of anything, that's called just the magnitude. They have the same magnitude, so I know it's going to be 1. The question becomes, is it going to be negative 1 or positive 1? Well, let's say I'm finding the limit as x approaches 4 from the left, which means that I am choosing numbers slightly smaller than 4. I'm choosing like 3.99999. So if I do 3.999 less than 4 minus 4, I get 0. Sorry, I get a negative number. But on the top, that number is going to be positive because it's always positive, because it's an absolute value symbol. So this would be negative 1. But if I were to do the limit as x approaches 4 from the right, the number on the top will always be positive because it's an absolute value, but now the number on the bottom would also be positive because I'm putting in numbers slightly greater than 4, 4.001, which is going to give me a positive number. So since I'm dividing a positive by a positive, I'm going to get positive 1. Well, we can from that then say that the limit as x approaches 4 of x minus 4 over x minus 4, what can we say about that? That does not exist. Why? The left-hand limit doesn't equal to the right-hand limit, so the limit itself does not exist. Okay? So that's basically what we're going to do. So if you understand that concept, you should be able to do the next few problems. Okay? So it's basically the same thing that we just did, except for now we're taking the limit as x approaches 2 from the left. So once again, I know that my magnitude of this is going to be 1 because I'm dividing by the same thing. And then I ask myself, I know the top is always positive. Will this bottom be positive or negative? Well, since I'm coming in with numbers slightly smaller than 2, 1.9999, slightly smaller than 2, my bottom number is going to be negative. So I have a positive divided by a negative. My answer is negative 1. Okay? Now, for this one, I have to factor first because I don't know that x squared minus 4 divided by x minus 2. They won't have the same magnitude. But if I were to factor this, and if I were to factor it correctly, I get x plus 2, x minus 2, all over x minus 2. Now remember from the properties that we did yesterday, I can write this as the limit as x approaches 2 of x plus 2 times the limit as x approaches 2 of x minus 2 over the absolute value of x minus 2. I can write that like that. Okay? So, because I'm looking at 2, and it's not from the left or from the right, I have to take both. So I have to take the limit as x approaches 2 from the left. And that quantity, if I approach 2 from the left, even though my numbers are slightly smaller than 2, I still end up with 2 plus 2, which is 4, times. Now, when I come in from 2 from the number slightly smaller than 2, this is going to give me a negative number, because slightly smaller than 2 would be like 1.999. So 1.999 minus 2 is going to be negative, but the bottom is always positive, so this is going to give me a negative 1. So the limit as x approaches 2 from the left would be negative 4. Then I have to take the limit as x approaches 2 from the right. That's not going to change this value at all, because when I come in slightly bigger than 2, I still get 4. And then as I come in slightly bigger than 2 here, the numerator becomes positive, because I'm doing like 2.0001, so that's positive. The bottom is always positive, so that's going to be positive 1, and I get 4. So what does this tell me? That the limit as x approaches 2, you got it, does not exist. Okay? Now this one brings us to what we're going to discuss in video 5. But basically, I have the absolute value, and because I'm taking the limit as x approaches 3, I have to look at the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. So as I substitute in values for 3 from the left, I am taking numbers slightly smaller than 3. Let's say 2.9999. So as I insert 2.999 into this, as I evaluate that with that, I get 1 over a pretty small number. And it's going to be negative, but I'm taking the absolute value of it, so that's going to make it positive. So because this is I'm dividing 1 by a really, really small number, if you try this on your calculator, what you're going to see is that you're going to get a really big number. So that's going to go towards infinity. The same thing on this side, I'm now going to have 1 divided by now still a positive 0.00001, because my values for 3 are like 3.00001. So when I subtract the 3, it's going to give me 0.001. It's positive, but we're taking the absolute value of it anyway, and that gives me infinity. So since the left-hand limit is equal to the right-hand limit, we can say that our answer is infinite. Now, if one were going to positive and the other one was going towards negative, then we'd have to say does not exist. Some books will tell you that the limit as if it's approaching infinity, that the limit does not exist. Because remember the first definition I gave you, I told you that the limit had to be finite. So some books would say this does not exist. Some people will say infinity. I would never give you an answer with both choices. I would not say infinity or does not exist. Okay, I would give you one or the other. Okay, let's do these 3 problems quickly. Basically the same thing. The 5 doesn't really make a difference until the end, because remember we can write this as 5, the limit as x approaches negative 2 of the absolute value of x plus 2 over x plus 2. And I just realized that that's a negative and not coming in from the left. So then we have to do 5 times the limit as x approaches negative 2 from the left, and the limit as x approaches negative 2 from the right. And we can see that when we're coming in from the left, my values are 1. And if I am coming in from the left, slightly smaller than negative 1 is what, like negative 2.001. So as I come in from the left, this is going to make this positive divided by a negative. That's going to be a negative 1. And as I come in from the right, I have numbers slightly bigger than negative 2, which would be like negative 1.999, slightly bigger than 2. So that's going to be a positive number. And so I get positive 1. So this limit does not exist. Because as I come in from the left, it's one thing. As I come in from the right, it's something. As I come in from the left, it's negative. As I come in from the right, it's positive. For this problem, we need to factor out a 2. Now, in most cases, I would factor out a negative 2. But since this has x minus 3, I'm going to keep it like that. So I'm just going to factor out a 2 and make this negative x minus 3. So that it looks just like it's what's in the bottom. Again, we're going to do the same thing, and since there's no direction to it, it just says as x approaches negative 3, we're almost at the point where we know that that is going to be does not exist. Because when we come in from one direction, it's going to be positive, from the other direction, it's going to be negative. So this does not exist. Okay? Last one, we're going to do 5. We're going to factor out that 5 and do x plus 4 over the absolute value of x plus 4. And we're taking the limit as it comes in from the right, meaning we know this will always be positive. This will always be positive. So as we come in from the right, the numbers are slightly bigger than 4. So my numerator will be 4 as well. I'm sorry, it's going to be positive as well. So then I have a positive divided by a positive, and I know that's going to be positive 1. So my answer is 5. Why don't you try the next 3, pause the video, and then after you pause the video, I will show you the answers. Okay, so there we go. Okie dokie. That's it for this video, and the next video is lesson 5, and we're going to look more at limits as they go towards infinity.